just a quick glance at the choices in the passage. I know this is going to be some dense science here, but my advice as always is just keep it simple. The question is asking us to complete the text. So we're basically trying to follow a kind of an argument, and there's going to be some sort of conclusion, and we're trying to guess what that conclusion is going to be. So keep it simple, and hopefully we can come up with a fairly obvious conclusion. Let's see. A team of biologists led by these people investigated the mechanism that allows this plant to accelerate flowering at high temperatures. They replaced this protein in the plants with a similar protein found in another species that, unlike the first plant, displays no acceleration in flowering. So, okay. Oh my God. So notice how I'm skipping all the science stuff because I don't care. So the stiff one has no acceleration. The thale cress, or they call it Thalania, so let's do that too. Yeah, the Thaliana accelerates flowering at high temperatures. That had no acceleration in flowering with increased temperature. Okay. A comparison of unmodified plants with the altered plants, so comparing the two, showed no difference in flowering at 22 degrees Celsius, but at 27 degrees Celsius, the unmodified plants exhibited accelerated flowering, while the altered ones did not. Which suggests, well, it just suggests that the experiment worked, right? Hold on, let me just make sure I get this, right? Normally, it accelerates at high temperatures. Here we have a high temperature, and it accelerated, so that seems good. The altered ones, the ones that had the no acceleration, though, they did not accelerate. So which I think I've got it. The experiment worked. Right? The modified stuff worked. It meant that the higher temperature didn't do any flowering. I'm assuming that's right. Let's just see. Okay, so it suggests that the temperature-sensitive accelerated flowering is unique to that plant. No. We are only talking about two plants, right? So this is a good example of a small to big problem. We have one experiment about this one plant and I guess some other similar plant. And now this choice is saying, well, now we're going to say that this Thaliana thing is so special in the context of all the plants in existence, right? It's unique to this plant. No, we just are only talking about these two. So we're not allowed to blow this thing up and make broad conclusions about all plants or how Thalania compares to all of them. We're not allowed to do that. So it's a very common trap. B, the Thalania increases this ELF3 production as temperatures rise. No, well, it's not about increases in the thing. It's only whether it has it or not, right? Remember the experiment is the ELF3 protein was the thing that was either turned on or off, right? It wasn't, did it have a lot or a little of it? It's not about an amount. So just be careful of words that start to quantify things. We have to prove those words. So ELF3 enables Thalania to respond to increased temperature. Yeah, right? Because that's what they thought, that the ELF3 did this, then they modified it by taking that protein out, and then it didn't, and then the experiment showed that the modified ones didn't do anything. So yeah, that's probably it. Let's just look at D. Temperatures of at least 22 degrees Celsius are required for Thalania to flower. No, because they're not saying that there were no flowers before that. We don't know anything that happened before 22 degrees Celsius, so we're not allowed to guess. I also just in general worry about choices that involve the idea of necessity, something that has to happen, right? I mean, in science, we very rarely have that kind of thing happening. We have, trends or likelihoods and probabilities, but something being required is very rare. So C is definitely the answer here. And like I said, this is basically confirmation the experiment worked. They had this plant, they took out the protein, they put it in a similar protein, but it's different. And then when they did that, it turned out that it didn't flower at an increased rate. So basically this protein that they changed was the thing that mattered, and choice C is saying this protein is the thing that matters. So notice I'm still kind of talking about all this science with as little scientific words as possible, and it's because I don't have the space in my brain for that. And that's not what it's about, right? It's about the logic of science in general. How do experiments work? What did we change? What's a control? What's an experiment? And so we just want to follow the logic of that. and all the stuff, the specific words and plants and whatever is just kind of window dressing, trying to help us understand those things, but it's really the more simple ideas in science that we're being tested on here.